So today I would like to go over how to do benchmarks in Rust. I was really curious about the topic because I'm now at the point of my Rust journey where I'm starting to write things and I would like to know how fast they run. So yeah, let's get it. Alright, so before we get into the topic of benchmark, we should probably define what it is. I went to Wikipedia and they state that in computing, a benchmark is the act of running a computer program, a set of programs, or other operations in order to assess the relative performance of an object, normally by running a number of standard tests and trials against it. The term benchmark is also commonly utilized for the purposes of elaborately designed benchmarking programs themselves. Alright, so basically the takeaway here is that a benchmark is when you try to run a set of operations or tasks or even a small piece of code over and over and over again in hopes of finding out its relative performance. So for example, if you want to test the Fibonacci sequence for range of, I don't know, the 50th Fibonacci number, you'll run that program, Fibonacci to the 50th, over and over and over again, like a time trial, and then you mark how long it took. Most languages have this in the standard library. If you go to Rust, look at tests, you can see that something exists. This is a nightly only experimental API. And then down here you see bench, that sounds kind of close to it, bencher, module, benchmarking module. Okay, so it does exist and there's not much documentation on it. And it's in nightly. Noted. So when I started digging further, I came across this document. This document goes over how to use the benchmarking test, like the one I just found in the library, in the standard library, in the nightly section. Anyway, this comes from, if you look up at the top here, doc.rustlang.org/1.7 book benchmarks. So seemingly, this was a part of the Rust book way back when in like 1.7. So at some point in time, this was removed from the Rust book. And recently, as in just now when I was searching through, I found out that in the Rust Unstable book, that same document is present. As in, it seemingly got moved from one book and put into the other. So probably at the creation of this book, it got moved. Anyway, let's start going through, right? The wording's a little bit different here. The internals of the test crate are unstable, behind the test flag. The most widely used part of the test crate are benchmark tests, which can test the performance of your code. Let's make our source lib look like this. And they have a feature flag, which I believe just allows you to use the test in an unstable state. They have an extern crate test, and then you just have a regular function. They have your test the way you would set them up normally. They import test bencher. They have a regular test, and then they have a benchmark test, which uses the attribute bench. They pass in a mutable bencher, and then do b.iter, pass in a closure, and seemingly it is within this closure that you write the code that you want to benchmark. And if you have any setup, that should be done outside of the closure. Note the test feature gate, which enables this unstable feature. So what does that mean? Test feature gate. What did these two things mean, seemingly? I had to do a little bit digging, but let's go with extern first. Keyword extern. Link to or import external code. Alright. The extern keyword is used in two places in Rust. One is in conjunction with the crate keyword to make your Rust code aware of other Rust crates in your project, i.e. extern crate, which is what we were seeing. And then the other use is in foreign function interfaces, FFI. Okay? And it looks, seems to be the usage of extern, So extern is used in two different contexts within FFI. The first is in the form of external blocks for declaring function interfaces that Rust can call foreign code by. And you have this sort of links thing here, right? So let's go back to test, see if we can find this. So we go to test, we look at source, we come down to about here. I see. So it's noted as a feature, which I guess hence the keyword feature that you have to use on top of the file. The feature is test. There's an issue associated with it, not exactly what that's about. We also know that it's a crate because it has a crate name here. Okay, that makes sense. Why is extern crate? And yeah, we know this is an unstable. Not exactly what that does, but I mean, it makes sense. And it's also feature test is also noted here. So this is noted in a few different places. So let's go back to the source. Here we go. So it kind of makes sense that this needs to exist. It's telling the compiler, you can use this crate. Makes sense that this exists. It's letting us know that this external crate exists and that we need to use it and that we will be using it. Okay. And then everything else is pretty straightforward. So let's copy this over to our editor and see what it does. And I have to open an editor. All right, so I copied the code over. Well, I created a library from cargo new lib and then name. And I copied the stuff over. We have our feature thing here. We have our extern crate thing here. One function, test section, test benchmark. And let's see if we can run it. So cargo, first let's do cargo test, see what happens. Got it. So as you see here, we get an error. May not be used on stable release channel. So that implies what we already sort of knew is that benchmarking isn't on stable Rust. So we need to figure out how to use unstable Rust. Let's go back to the links. I believe I have that here. So Rust up for managing Rust versions. We know that benchmarking is in the unstable version or nightly. So one thing we have to do is install that tool chain. And you can do it just install nightly. This specific example is just demonstrating how you can install a specific version of nightly. But you can do Rust up toolchain install nightly and that works. This is noted right here. And then in terms of updating your tool chains, all of them, Rust update will do that. But other things that you can do is if you have a situation where all of your code needs to be benchmarked, that means all of your code needs to be run on nightly, then you may want to change your default Rust toolchain version, which you can do that as well, set the default to nightly. Alternatively, you could periodically run nightly, as in do plus nightly, and it'll tell, this command tells the toolchain to use. This command specifies which toolchain to use, and it's saying just use nightly. It's short for this command. And you can use run, build, yada, 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 test. But alternatively, and what I thought was really cool is that you could override the toolchain for specific directories or on the per directory basis. So if you have one project that needs to be benchmarked and others do not, then for that specific project, you can set the Rust toolchain for that directory to be nightly. So let's do that real quick. And I've already installed nightly on this machine, so that should be fine. Here we go. Well, actually, before we do that, let's do the plus nightly so you know that it works. Nightly test. Get rid of you. And test pass. Bench add 2 looks like it ran, right? but we didn't get to see any of the measured information about it. So if we do, there's another command, cargo, let's make this bench. Cargo bench will skip the regular test and simply just do the benchmark test. And then it will give you the information that you want, the performance, nanoseconds over iteration. I don't know if it does any other measurements in terms of units of measure used, but nanoseconds is pretty standard. Alright, let's do the override to nightly. And now let's run this command without bench. And yeah, it ran because our toolchain is now defaulted to nightly. Some things to note is I tried moving these to different locations to see if I could run my code using stable and test my code using nightly. It didn't really work out. The whole feature flag thing puts a damper on a lot of things. So if you do it this way, then it's seemingly your entire project has to be nightly, but I am not positive on that. That's just what I perceive it. That's what I think it has to be. So while in my pursuit to figure out how to do benchmarking, I would really love to do benchmarking on Rust Stable. And I did find a crate that adheres to that. So there's this crate called Criterion, which is seemingly a port of a benchmarking tool in Haskell. Anyway, it says here, Criterion helps you write fast code by detecting and measuring performance improvements or regressions, even small ones, quickly and accurately. You can optimize with confidence knowing how each change affects the performance of your code. Okay. On the surface, because I did take a look at this, they not only benchmark, but they also add a statistics perspective to your code and your stats. They'll give you charts, which charts you have to install GNU plot in order to be able to generate the charts. The statistics that are used, I did not truly understand because I'm not all that great at statistics, but there are a number of different statistical analyses that are done and that are shown to you. And they also compare the previous runs against the newer runs, which they stated in the opening statement here. And they do that by saving all of the, well, I'm not sure if they save all of it, but they at least save the most recent run in your Rust project so they can compare against. For this video, I'm going to go through the quick start just so we get a sense of how to use this tool. So I created a new library project, called it Rust Criterion, right? And I think one of the first things they wanted me to do was to update my cargo.toml file. And they want me to put this stuff in here. So we have dev dependencies, Criterion 0.3, and then we have this thing called bench. And we put a name to it, and we say harness equals false. One thing I was really curious about is, what do they mean by harness? And I think I have an understanding. Okay, so in the cargo book, section cargo test, they talk about harnesses. Here's what they state. Well, I mean, the word's right here, but let's start from this top. Tests are built with the --test option to Rust, which creates an executable with a main function that automatically runs all functions annotated with the test attribute in multiple threads. Bench annotated functions will also be run with one iteration to verify that they are functional. The libtest harness may be disabled by setting harness equal false in the target manifest setting, in which case your code will need to provide its own main function to handle running tests. I see. So basically what they're stating here is that Rust comes with a test harness, and a test harness is the mechanism or the main function used to find your test and then run your test. So for us to make hardness equals false means that Criterion has to supply a main function to run the benchmark test. And I'm not positive about this, but I think if you turn off the hardness for bench, that has nothing to do with the hardness for a test. Like test may be a tag in the manifest that you can change. All right, so going back to here. So we see that the hardness is set to false and that the name is my benchmark, right? Okay. This, I believe, is naming the entry point for the benchmark test. So let's copy that over real quick and then continue. All right, moving onward. And this is big enough? I'll make this a little bigger. Next, define a benchmark by creating a file, benches, my benchmark, rs, with the following contents. Okay? So, benches, which I believe is the place that Rust is going to look for benchmark code, and then put the my bench, which is the name of that we associated with our benchmarks. And if we look at this real quick, they wrote a Fibonacci sequence, recursive, okay. They imported the use of black box, Criterion group, and Criterion main. So I assume Criterion main is the main function that's going to be used as the test harness, right? And group, I'm not exactly sure what this does, but seemingly notes which tests are going to be run together. In this case, we only have one, so it's a group of one, but I think you could also do groups of multiple so that the results can be compared directly to each other. And when I say directly compared to each other, I mean in the sense of some of the stats might be compared directly to each other, some of the charts might be a direct comparison, and things of that nature. And then here we see that the Criterion benchmark, here's the test function. There's no need for a test or anything like that because they're using their own way of writing tests. We pass in a mutable Criterion thing, and we use it similar to the way we use the other one, the one in the standard library, which I believe this is built on top of that. We do bench function, we give it a name, and we pass in a closure that runs the stuff. That runs the thing that we want to test. All right, so let's do this as well. Let's copy this over. Benches my benchmark. Here. Alright, I copied the code over. Now let's see what the next steps are. Finally, we run the benchmark with cargo bench. You should see output similar to the following. Alright. Okay, so it noted that GNU plot is not found, and then it started running stuff. I see. So based on what they have here, one test was ignored. And then we have the results from the benchmark, and this is how they come out, at least without doing verbose mode. We have the time it took in US. It should be noted that this is not nanoseconds. It took me a really long time to figure out what US meant, and US, it's not actually a U. It's supposed to be like that weird, let me just find it. It's microseconds. Here, let's do this real quick. Microseconds. It's this symbol. So if you want to do microseconds to nanoseconds, let's do that real quick. Microseconds to nanoseconds. 1 microsecond is 1,000 nanoseconds. So I point that out to say this. When you look at the results when using Criterion, you have to make sure you understand the unit of measure that they're giving the results in, because it does vary. Sometimes you get nanoseconds if something is that fast. Sometimes you get microseconds if something is that slow. And we have outliers, which I know what outlier is in terms of statistics, but I do not know exactly what that means in terms of this. Outliers, at least from my understanding, are runs that exceed the normal time limit or normal expectations. So there were 8 cases. I don't know how many times this ran in total, but in 8 times there were results that were outside of what we expected to be the normal results. And we gain the reason we have an expectation of the results to be in such a way is because most of the results are fall within a specific time period. So that's what we get if we just run it regular. Now if we do benchmark-v, it notes that GNU plot is not here, which I'll fix that after this run. I see collecting 100 samples, estimated, analyzing. Okay. So here with the -v to make it verbose, we have the time like we had before. Change, I'm not sure if that's with -v or not -v, given that the first iteration was the first time we ran it, so there was no historical numbers to compare against. Now there are. So it's telling us what the change was. Change within noise threshold. Not sure what that means. They give us the outliers. That's about it. So we have a little bit more information. So this GNU plot, what does that give us? Let's go and install it and figure it out. So on the crate.io page, they have a link to it. And more or less, we figure out GNU plot is a Linux tool. So if you want to install it, you simply just have to use your package manager on Linux, or maybe follow the instructions for other platforms. Alright, so I went to my terminal, installed it via the package manager, and now let's try to run this again. Note it did not give me the message saying that GNU plot is not installed. Dun dun dun. Things got worse in terms of performance. This is awkward and strange, but it's good to have measurement and numbers. So what we really want to see is the GNU plot stuff, right? In Target, Criterion creates a directory. In the directory, it hosts the reports and all the other stuff. We can do tree real quick just to see what's here. It has all the images individually, has an index.html for, I believe, the charts and overall results. It has the raw CSV for entries, for things that were tracked. So let's open the index, right? Firefox report index. And we have the report for this. So this is what I meant by this crate gives you a lot of information. And also you have to note the unit of measure. We have the average times in US or microseconds. They give you a density chart, iterations, total sample time. They give you slope, linear regression, mean, standard deviation, median. I have no idea what MAD stands for, but MAD. They give you a little excerpt about understanding the chart. Let's make this a little bit bigger. Text looks kind of small. It says the plot on the left displays the average time per iteration for this benchmark. The shaded region shows the estimated probability of an iteration taking a certain amount of time, while the line shows the mean. Click on the plot for a larger view showing the outliers. Is that the for here? Oh, if you click on the chart, it gives you more information. Wow. This I did not know. That's really cool. Does that do... No, I mean, that just gets you a zoom in, but nothing particular there. Okay. Changes, so they give you the information about changes. And it looked like they only compare the previous run, because there's only two things here. I see base and new. So maybe just 2 instances. But still, that's pretty cool. So one last thing I'd like to go over before I end this video is there was an article written by, if not the creator of this crate, one of the maintainers. And I think I have that. Here we go. And I'll link this in the description. But like it goes over, this was written in 2018, January. So this was written a while ago for a very different version. And they go over some of their thoughts, example how to use it, yada yada yada. But what I thought was very insightful is they have pitches for why do we want to use this and pitches for why you may not want to use this. More or less, at least in summary and my perspective, y'all should definitely read this yourself to gain your understanding of it. But the pitches for using it are that you can use it with Rust stable, and it gives you a lot of information. And it's sort of built off of the lib test, and people are continuously working on it. We have different iterations and versions of this coming out. The pitches for not using this, at least according to them, are 1, you have no issue using the one in the standard library, which means you have no issues using nightly or unstable Rust to do your work, and you need something that runs fast. I think they note in this that this crate, Criterion, isn't the fastest in terms of being able to run your tests, or at least run your benchmarks. Yeah, so that was benchmarking in Rust. If you liked the video, hit like, subscribe, yada yada yada. Till next time. Peace.